Cats. We're going to discuss today the unit circle. We've talked about this a little bit, but I want to go into depth a little bit more. This is the equation of a basic unit circle with a radius of 1, which is what we've been talking about in class mostly. We have already discussed our rotations in degrees and our central angle, or our rotation in our degrees and radians. Now we're going to talk about the ordered pair along the circle. It's like you imagine that the outside of the circle, you've wrapped a number line around the outside of that circle, and we want to know what the ordered pair is at that circle. So I want to know at 30 degrees what that ordered pair is. So I would have an x value, and then I would have a y value to get to that ordered pair. And I want to know what that is. And we know that's a 30-degree rotation, so our theta is 30, our pi over 6. But what I want to know is what the ordered pair is. We're going to, I'm going to go and give you these ordered pairs, and you're going to start to memorize them. But I'm going to also go in the next little section and show you how we found those ordered pairs algebraically with right triangles. We'll go into more of that even in the next section. So we have this ordered pair. We're going to have this ordered pair. And we're going to have an ordered pair for 60. Those are our special angles. Of course, if the radius is 1, then this point on the circle would be at 1, 0. And if this radius is 1, then this would be at 0, 1. And then over here, this would, of course, be negative 1, 0. And down here would be 0 and negative 1. So there's our big 4. We really only need to know the big 4, and we need to know our 30, 60, and our 45 and 60 degree values of our ordered pairs, because they will mimic those same values regardless of the quadrant we're in. It'll just depend on the sign value will only change. So in this quadrant, we would still have a 30-degree angle. Our x value would be the same, and our y value would be the same. But in our ordered pair, our x value would be negative. So that's be the only difference. So really the same values, just the negatives. And of course down here you'd have the same thing. You would go down like this. I didn't do a very good job of that. Sorry. That's a terrible job. And this point at 30 degrees would be the x and the y would both be negative. And over here, we move up to the x-axis. And over here, this point, of course, the x would be positive. Oops. Sorry about that. I need to erase. Yeah. Oh, positive, sorry, I'll make that a positive. And the y value would be negative. So, I'm going to go ahead and give you these 3 sets of ordered pairs, and those you're going to start to memorize. For 30 degrees, the x value will be the square root of 3 over 2. And I'll show you how we find that in a minute. And the y value is 1/2. Now, what we're going to learn, as soon as you know the 30-degree angle, you know the 60 because they just reverse. In the 60-degree angle, the x value is 1/2, and the y value is the square root of 3 over 2. For 45 degrees in the middle, remember in a 45-degree triangle, the x and the y values would be the same, and they happen to be the square root of 2 over 2 and the square root of 2 over 2. The last thing we're going to learn is that our x value is actually going to correspond with our cosine value, and I'll show you why in a minute, and our y value is going to correspond with our sine value. So those are really important. The last thing that we're going to learn is we're going to go ahead and learn our tan values, because they're pretty easy, and you don't want to have to go through and figure them out each time. Tan is y divided by x. And you're going to trust me right now, and if I tell you that if I take 1/2 and divide it by the square root of 3 over 2 and rationalize the denominator, you're going to end up with the square root of 3 over 3. And for 60, you're just going to end up with the square root of 3. So there's some correlation there. And in the middle, if you divide the square root of 2 over 2 by the square root of 2 over 2, you'd end up with 1. So that's our tan value. So those are going to become very, very important values, and we're going to write them in tables. We're going to write them in different forms, but they correspond to the points on the circle at our special angles. Now, next I'm going to go ahead and explore a little bit how we found those values at 30 degrees and just show you. We will do more of that in the next section, but I do want you to kind of have a good understanding of that. So, I'm going to want you to imagine for a minute that this is the 30-degree angle in our unit circle. And, of course, the circle is a little bit further out here. You know that. And this was that point at 30 degrees. So this was our pi over 6 angle, and this was the ordered pair that we found. And remember, in this circle, in the radius, the hypotenuse is of this right triangle is the radius, and in a unit circle, it's 1. And what do you know about 30, 60-degree triangles? We know if this is a 30-degree angle and this is a 60-degree angle because this is your right angle. And across from 30 was your x value. You knew this from geometry. Across from 60 was your x square roots of 2. And, of course, the hypotenuse was equal to 2x. So let's start exploring. If the hypotenuse is equal to 2x and the hypotenuse is 1, then x would have to be 1/2. So x would have to be 1/2. And x square roots of 2 would be 1/2 square roots of 3. 1/2 square roots of 3, which would equal the square root of 3 over 2. And those were our values a while ago. Remember that this would be our x value in our ordered pair, which would be the square root of 3 over 2. This would be our y value, which would be 1/2. Now, let's talk a little bit about why it's cosine and sine. You remember also from geometry that if you have an angle, then you have an opposite side and an adjacent side. And you remembered that SOHCAHTOA, that sine was equal to opposite over hypotenuse, and cosine was equal to adjacent over hypotenuse, and tangent was equal to opposite over adjacent. So let's talk a little bit about this. So if we're in the angle, opposite would be here, which would be our y value over our hypotenuse. And the y value happens to be 1/2, but it's divided by 1, which would equal just 1/2. So sine is equal to 1/2. For cosine, it's the adjacent side, which happens to be the square root of 3 over 2. So that's our x value is our adjacent over hypotenuse. So that's the square root of 3 over 2, but the hypotenuse is 1, so it would just be the square root of 3 over 2. So cosine is the square root of 3 over 2. So x is cosine and y is sine. And then finally, tan is opposite over adjacent. Well, opposite would be the y, adjacent would be the x, and in this case, the y value is 1/2, and we would be dividing by the x value of the square root of 3 over 2. And I'm just going to go through the math here. So we would have 1/2 times 2 over the square root of 3, which would give us 2 over 2 square roots of 3. The 2's would cancel out. We would have 1 over the square root of 3. 1 over the square root of 3, if we rationalize it by multiplying by the square root of 3 over the square root of 3, gives us the square root of 3 over 3. And that is our tan value. Now, that's a lot to have to go through each time you want to find those out. You're going to use them for the special angles over and over again, and I strongly, strongly suggest that we just memorize those. So I'm going to go back to that first screen. Actually, I'll just do it one more time for you. So we're going to go ahead and imagine, this is our circle, even though I'm not drawing the circle in, and we're going to imagine that we have a 30 degree and a 45 degree and a 60 degree. And the ordered pair at the endpoint of the x-axis would be at 1, 0. Now, what would tan be? That would be y divided by x. So 0 divided by 1 would also be 0. So then we're going to have the ordered pair at 30. And we just discovered that was the square root of 3 over 2, 1/2. And the square root of 3 over 3 for tangent. We're immediately going to go up to the 60. And we're going to reverse our x and y, make it 1/2, the square root of 3 over 2, and then just the top, the square root of 3. And then remember at 45, the x and the y values should be the same, and they are the square root of 2 over 2, the square root of 2 over 2, and then 1 for tangent. So this is our cosine, our sine, and our tangent values, which are our x and our y over x values. Now, the nice thing is up here at the top, we said before we would have 0, 1. Our tan value would be 1 divided by 0. Anything divided by 0 would be undefined. So at 90 degrees, or pi over 2, tangent is undefined. Cosine is 0, and sine is 1. That's what we want to know. That's the value at that point. Over here, we had -1, 0, and 0 divided by -1, again, would be 0. And down here, we have 0, -1, and -1 divided by 0 would also be undefined. Now, as I said before, once you know these, then you really know the whole circle. You just have to think about your quadrants. This is quadrant 1, and everything is positive in quadrant 1. In quadrant 2, your x values, or in this case, your cosine values would be negative. Therefore, if you're dividing by a negative, your tan values would be negative, and the only thing that would be positive would be your sine values. So all would be positive here, sine would be positive here. So for example, at 30, you would still have the square root of 3 over 2 and 1/2 and the square root of 3 over 3. But the cosine or the x value would be negative, making this also a negative. So the only one that would be positive would be your sine value. In the third quadrant, at 30, you would also have the square root of 3 over 2, 1/2, and you would have the square root of 3 over 3. And this would be cosine, sine, and tan. Here, your cosine would be negative, your sine would be negative, but negative divided by negative would leave your tan as a positive. So your tangent would be positive. So I'm going to put a T there for the positive one. S here for the positive one. All, A for all, are positive here. And finally, in the fourth quadrant, you would again have the square root of 3. This is all for 30-degree reference angles. So these angles are all 30 degrees. You would have the square root of 3 over 2, 1/2, and the square root of 3 over 3. Sorry, this is so messy. And in this quadrant, the x value would be positive, this would be negative, and therefore your tangent would be negative. So cosine, sine, and tan, cosine would be the only positive value. So A, S for sine, T for tan, and C for cosine. Tomorrow, ask me in class the little special way, the California way, to understand those values. Last, I want to go over odd and even trig functions. And there's really just something that you need to memorize about these. We're going to talk about even and odd trig functions. And what you really need to know is that cosine and secant are even. So both of these are even functions. And you knew in the past what that meant is if we substituted a negative value, then it would come out to be what the original equation was. So in other words, if we had a positive equation and we substituted a negative, it came back out to be positive. If we had a negative to begin with and substituted a negative, it came back out to be negative. It came back to be what it was originally. They became even again. So it would look something like this. You would have cosine of negative t is equal to cosine t. And secant of negative t equals secant t. And therefore, the other four trig functions are odd, and that would be your sine, your corresponding cosecant, which is its reciprocal, your tan, and your cotan. And these are all odd functions. So in this case, you have sine of negative t, and it would equal a negative sine t. And you have cosecant of negative t, and it would equal a negative cosecant t. And you have tan of negative t, and equal a negative tan t. And finally, cotan negative t would equal a negative cotan t. All right, that's just more memorization than anything. We'll use that a little bit. But the values that we talked about earlier are very important, and we will use those throughout the rest of the year. All right, go Bearcats.